Welcome to Kentucky Sky Talks, a monthly series of astronomy presentations for nearly all ages, brought to you by the University of Kentucky Department of Physics and Astronomy in cooperation with the on-campus MacAdam Student Observatory. Free and open to the public, these talks can be attended in person on the UK campus or else via YouTube live stream. Everybody is welcome. This evening, we'll be talking about solar eclipses. As you all know, I'm sure, on April 8th of this year, there will be a total solar eclipse visible in some places. Don't you dare miss it. I'm your presenter for tonight, Tom Troland from the UK Physics and Astronomy Department, and I would like to answer some questions that you might have about solar eclipses. For example, what causes a solar eclipse? And what do you see if you're here on the Earth looking up at a total solar eclipse? Where need you be on April 8th, 2024 to see a total solar eclipse? And what will you see from Lexington? You will not see a total solar eclipse from Lexington, although it will be an interesting view, if the weather permits, of course. We'll talk also about how you can protect your eyes. It's very important to use proper eye protection during a solar eclipse. And finally, we'll talk about when future total solar eclipses will occur in North America, and for that matter, when the next total solar eclipse will be visible here in Lexington, Kentucky. Don't worry about that latter date because none of us alive today will be alive then. We'll see. First of all, what causes a total solar eclipse? Well, as you all know, the moon orbits around the Earth in about a month. And during that orbit, at a certain point, the moon lies more or less in a straight line between the sun and the Earth, as you see in this diagram. That's the phase of the moon known as new moon. When the moon lies between the sun and the Earth, if everything lines up exactly, then the shadow of the moon will be cast upon the Earth. And as you see here, and as I mentioned earlier, this can only happen during new moon. Now, as the moon moves in its orbit around the Earth, the dark shadow of the moon, known as the umbra, traces out a path across the Earth over a period of several hours. And this path is called the path of totality. It's different for each eclipse. Here's another illustration which shows the same thing from a slightly different perspective. As the moon moves, its umbra sweeps out this narrow path of totality, as I said, across the Earth, never more than about 170 miles wide, usually not as wide as that. You see in this illustration the moon in the lower right. And the shadow of the moon is now tracing out a path across the Earth. The moon casts a tapering cone of a shadow called the umbra. That's the region of the moon's shadow for which all direct sunlight from the sun's disk is obscured. And then the penumbra is a widening cone shown there in a lighter shade of gray. That's the region of the sun's, rather the region of the moon's shadow, I should say, in which only part of the sun's disk is blocked. So over a period of several hours, as the moon moves in its orbit around the Earth, its shadow traces a path across the Earth. And if you are on the Earth and within that shadow, then you see an eclipse of the sun. The key point here is that in order to see a total eclipse of the sun, in order to be in a position where the entire disk of the sun is blocked by the moon, in order for that to happen, you have to be in this narrow path called the path of totality. Even if you're not in the path of totality, but are somewhere outside the path of totality, but still within the penumbra, you will still see what's known as a partial eclipse of the sun. Here now is an animation that shows a solar eclipse that many people hearing this talk may have witnessed themselves. It's the solar eclipse of August 21st, 2017. And in this animation, you see the eclipse carried out over a period of a few hours. The little black dot that you see there is the umbra of the moon tracing its path of totality across the Earth. And the larger gray region represents the part of the Earth that is exposed to the penumbra of the moon. the part of the Earth that's exposed to what's called a partial eclipse. This whole procedure, this whole process of the moon's shadow sweeping across the Earth typically takes 4 or 5 hours. And on August 21st, 2017, many of you were in that shadow, and the lucky ones of you were in the path of totality where the eclipse is total. And that event is an incredibly impressive phenomenon to see. It is almost certainly the most spectacular event in nature that can be predicted in advance. Here is now a diagram that shows the path of totality and the region exposed to the moon's P number during that eclipse. In this diagram for the eclipse of August 21st, 2017, you see the narrow path of totality shown between those blue lines. And then the hatched area that you see is the region of the Earth that was in the P number of the moon during the eclipse. So in order to see a total eclipse on August 21st, 2017, you had to be in the path of totality at the time that the moon's dark umbra swept past you. If you were within the hatched regions, which of course, as you can see, encompass the entire North American continent, then you would have seen a partial eclipse of the sun, with the moon only covering a part of the sun's disk. Here's the path of totality for the eclipse coming up in just a few weeks. The eclipse of April 8, 2024. Once again, you see the path of totality, and you see the crosshatched region, which shows the much larger region in which a partial eclipse of the sun is visible. So only those who are in the path of totality at the right time are treated to this extraordinary event known as a total eclipse of the sun. Lexington is unfortunately not in the path of totality of this eclipse. So folks in Lexington on this day, April 8th of this year, will not see a total eclipse, but instead see an eclipse in which about 95% or a bit more of the sun's disk is covered up by the moon at mid-eclipse in mid-afternoon. We'll talk about that later. Here's an interesting eclipse. This one is one that was observed on March 9th, 2016. You see the path of totality, which in this particular case traces mostly across the Pacific Ocean. You see the continent of Australia there, more or less towards the bottom of the diagram, and then parts of Asia in the upper left. But I show you this path of totality, this eclipse diagram, because this eclipse was imaged by a remarkable spacecraft that is in orbit around the sun, always between the Earth and the sun, always looking back at the Earth to study the Earth's climate. And that spacecraft was able to take pictures of the shadow of the moon sweeping past the Earth on that day of March 9th, 2016. Let me show you these pictures. It's a remarkable series of images. Here you see the full Earth as seen from the Deep Space Climate Observatory in orbit around the sun, between the sun and the Earth. And that spacecraft is looking back at the Earth, and you see now a full Earth. You see Australia in the lower left there, and you see the beautiful clouds that make up this blue marble that is our Earth. So let's move on now. 20 minutes later, you see now the shadow of the moon there on the left that's starting to sweep across the Earth. And 20 minutes after that, the shadow has moved more. This is the shadow of the moon that is sweeping past the Earth. And people on the Earth, or in this particular case for this eclipse, I guess in a ship at sea, who were in the shadow would see the solar eclipse 20 minutes later, 20 minutes later, 20 minutes later, and so forth. 20 minutes later, 20 minutes later, as the shadow of the moon sweeps across the Earth, creating a solar eclipse as seen by Earth-based observers. And finally, of course, the shadow sweeps past the Earth, still visible in this image, still barely visible in this image, and now gone. And you can still see the continent of Australia there towards the bottom of the screen and parts of Asia towards the top. So this is what an eclipse would look like. A solar eclipse would look like if you could view it from space, looking back at the Earth as the shadow of the moon passed by the Earth. Another interesting eclipse from the past, although we will talk about the eclipse coming up very soon, but another eclipse from the past is the one that was visible in December of 2021 in Antarctica. You see, with each eclipse, the shadow of the moon sweeps out a different path across the Earth. And in some occasions, the shadow of the moon just barely sweeps by the north or south polar regions of the Earth. And in this particular case, it was the south polar region. Here you see now a total eclipse sun, as seen, as you can see, from an aircraft looking down above Antarctica. And it's interesting to realize that in this picture, you are seeing the actual shadow of the moon in the shadow of the Earth's atmosphere. Because these lines that you see here represent the edges of the moon's dark shadow, the moon's umbra, which caused this eclipse. And here now is an image of the shadow of the Earth for the same eclipse as you see passing by the continent of Antarctica in this image, which also shows the beauty of the Earth. You see Africa, you see parts of Asia towards the top of the image, but the shadow of the Earth is, the shadow of the moon rather, is what is keeping this Antarctic region of the Earth in darkness for a period of time. Here is now another image of that same eclipse in December of 2021. And here you see now, looking down from the International Space Station, just a little bit above the Earth's atmosphere, orbiting around the Earth every 90 minutes. Now, on that occasion, astronauts were able to see that same shadow of the moon falling on the Antarctic regions of the Earth. A beautiful sight to be seen. Now, keep in mind that in December in the Southern Hemisphere, it is summertime. And in December in Antarctica, it's not only summertime, but it's the time of the midnight sun. It's the time of 24 hours of sunlight. So here now is a really amazing image of this same eclipse of December 4th, 2021. This was taken from Antarctica, and on that day, in the middle of Antarctic summer, the sun was above the horizon 24 hours. An enterprising individual set up a camera on a tripod with a special so-called fisheye lens, which has a 180-degree field of view. So this circular view that you see in this image represents the horizon. And every hour, this camera was opened up briefly to take an image of the sun. If you count those little dots there around that circle, you see the sun every hour for 24 hours. And one of those images, the one at the bottom, you see the arrow, was taken when the sun was totally eclipsed by the shadow of the moon on December 4th, 2021. So what do you see during a total solar eclipse here on Earth? Here is now a time-lapse sequence where a tripod was set up to observe a total solar eclipse. And each image is about 5 minutes apart in time. Time begins in the upper left, moving to the lower right. And so you see the progress of this particular eclipse over a period of 3 hours, maybe a bit more than that. The eclipse starts in the upper left before the moon has really begun to obscure the disk of the sun at all. And as time goes on, 5 minutes after 5 minutes after 5 minutes, more and more of the disk of the sun is obscured as the moon moves more and more in front of the disk of the sun. So it takes about an hour and a half or so for the moon to completely cover up the sun. And that period of time of an hour and a half or so, when the moon is only partly covering up the disk of the sun, that part of the eclipse is called the partial eclipse. And as we'll see later, in observing a partial eclipse, you must be very careful to use proper eye protection to avoid damaging your eye. Then after an hour and a half or so of partial eclipse, as you see towards the center of this time-lapse sequence, the moon moves directly in front of the disk sun. And at that time, all of the bright light of the disk sun is now obscured for just a few minutes. And the much fainter but beautiful outer atmosphere of the sun, called the corona, is visible. Here is now a more detailed picture of the corona. And what you see in this picture is a totally eclipsed sun. The moon is covering up all of the disk of the sun. We are seeing the silhouette of the moon. The silhouette of the moon is that black circle you see in the picture. And those streamers of light that you see are the sun's outer atmosphere, called the corona, where particles from the sun are being blasted out into space, following the lines of the sun's magnetic force. Here are now a couple of other images that show total solar eclipses. And you can see from these images that the corona of the sun's much fainter outer atmosphere, changes shape over time. So for each solar eclipse, the corona has a different appearance. And in each case here, as I mentioned previously, the dark circle represents the silhouette of the moon. The new moon is just in front of the disk of the sun, covering up all of the light of the disk of the sun. And so the corona is visible in both of these pictures. The corona is 1,000,000 times fainter than the disk of the sun. The corona alone is about as bright as the full moon at night. So if you witness a total solar eclipse, as the lucky photographers did in the case of these two eclipses, if you witness a total solar eclipse, the sky gets dark during that few minutes when the moon completely covers the sun's disk. The sky gets dark. It's about as dark, typically, as it is on a night of a full moon. In short, during a total solar eclipse, what starts out as a perfectly reasonable, bright, sunny day, if the weather is good, then gradually evolves into a brief few minutes of the near darkness of night, as the entire disk of the sun is covered up by the moon, just for a few minutes. A total solar eclipse. Here's another view. This was taken with special techniques involving multiple exposures and digitally adding up all of those images to create this beautiful view of a total solar eclipse. It's the one of August 21st, 2017 that some of you, the lucky ones among you, happen to see, but you would not have seen it in this same detail. But what you see are those beautiful tendrils of the faint light of the sun's outer atmosphere, of the corona. And each of those tendrils represents regions of the sun's atmosphere where material is being blasted out into interplanetary space along the lines of the magnetic field of the sun. Well, what about the eclipse of April 8th, 2024? That's the one we're interested in. Where do you have to be to see a total solar eclipse on that day coming up very soon? Well, the answer is, as is true for all solar eclipses, to see a total solar eclipse, you have to be within the path of totality. That's that narrow strip of the Earth's surface shown in this diagram in blue. That's the region where the moon's umbra sweeps across the Earth over a period of a few hours. And the region within the cross-hatched area shown in this diagram, as I've mentioned previously, that region is the region where the sun can at best be only partially covered, as seen by observers there. So to see a total solar eclipse, you have to be in the path of totality. Here is now a map of the path of totality, now just shown crossing across the United States and parts of Mexico and just barely into Canada. This is where you have to be, and as close as reasonably possible to the center of the path of totality is best. That's the blue line that you see there. And as you can see from this diagram, the path of totality strikes North America in Mexico and then passes through Texas and various states, Arkansas, Missouri, Illinois, Indiana, Ohio. The path of totality just barely clips the western part of Kentucky. Now you see Lexington. Lexington is close to the path of totality, but not within the path of totality. So as seen from Lexington, the eclipse is not a total eclipse. The sun's disk will never be covered by the moon during this eclipse, but rather at peak eclipse, the sun's disk will be 95, 96% covered, as seen in Lexington. Here is now a zoom in, showing more details. You can see that the path of totality, that magical place where the total solar eclipse is visible, the path of totality shown in grayed in colors here. The path of totality includes Indianapolis, includes Cleveland, it includes Buffalo, and many other places in between, but does not include Lexington. And now here, we zoom in one more time. And now you see the path of totality in our more or less immediate vicinities. So Lexington, again, not in the path of totality. Indianapolis, a little bit past the center of the path of totality. So if you wanted to see a total eclipse of the sun on April 8th of this year, one way to imagine doing this would be to drive from Lexington to, say, Cincinnati and take Route I-74 towards Indianapolis and stop anywhere you can find someplace to stop once you get well past Cincinnati. Or alternatively, you could drive from Lexington to Louisville. At Louisville, you could get on I-65 again, headed towards Indianapolis, and drive some distance into the path of totality and just stop anywhere. Stop at a service station, stop at a shopping mall, anywhere you can stop at a road stop, a rest stop. Of course, I have no idea what the traffic will be like on that day. So if you wish to make a lightning strike on the path of totality on April 8th of this year, you may want to plan ahead and leave pretty early on these interstates or find some other route. Of course, eclipses are only as good as the cloud cover is on that particular day, only as good as the weather is. No matter how well you plan to be within the path of totality or wherever you plan to observe the eclipse, if the sky is cloudy, you're, well, clouded out. That's always the disappointment that people worry about when they go to see eclipses of the sun. And what you see here is a map that shows statistics of cloud cover during the month of April over the United States. And the bluer regions are regions that have more cloud cover, and the yellow regions in particular are regions that have less cloud cover. So if you wanted to be located in the path of totality and you wanted to have the best possible chance of seeing the eclipse, statistically the best possible chance of clear weather, then you'd probably want to go to somewhere in Texas. But not everybody necessarily wants to plan to make a trip of that length. And therefore, for those of us who are in this general part of the country, in the Kentucky area, we most likely would be observing the eclipse as a total eclipse somewhere in the path of totality closer to, well, Lexington. And judging from the colors there, it looks like on the average in April, Lexington has about a 2/3 cloud cover, which is a way of saying that statistically speaking, as seen from Lexington or as seen within the path of totality, for example, in the Indianapolis area, statistically speaking, people around here who wish to see the eclipse have about 1 chance in 3 of having clear weather. That's just the way it is. Nothing we can do about it. But we have to hope for the best. And I have in my lifetime tried to see 6 total solar eclipses, and I have seen under clear skies 3 out of that 6. So I don't know whether I will be 4 for 7 or 3 for 7 after this eclipse coming up. So what will we see from Lexington? Well, here are the times. On that day, on April 8th, 2024, a little before 2 o'clock in the afternoon, the partial eclipse will begin. That is to say, the moon will just barely begin moving in front of the sun, creating the appearance of a slight bite taken out of the disk of the sun. And that bite will grow larger over time until here in Lexington, a little after 3 will be the maximum partial eclipse. At that time, 97% there or thereabouts of the sun's disk will be covered by the moon. And so the landscape will be darkened, although the eye tends to adjust to this reduced solar illumination during an eclipse. So the effect is not quite as dramatic as you might imagine. But still, as seen here in Lexington, a little after 3 p.m. on April 8th, the landscape will be darker and you will notice it. In fact, even if it's cloudy, you won't see the sun, of course, but at least you will sense this growing darkness. And then as time goes on after 3:09 p.m., the moon will move more and more away from blocking the sun. More and more of the sun's disk will become visible. And by 4:20 or so, the partial eclipse will end. That is to say, the sun's disk will now be completely unblocked by the moon. Now, this brings up an interesting phenomenon that you might look for during this eclipse here in Lexington, or even if you're in the path of totality. On an ordinary sunny day, sunlight filters through tree leaves, creating little round images of the sun on the ground. It's something known as the pinhole camera effect. On an ordinary day, the disk of the sun is unobscured by the moon, and so the disk of the sun is a circle. And so as you look at this image, a picture I took in Lexington not too long ago of light filtering through tree leaves, you see those little round dots. Each round dot, as I say, is an image of the sun on an ordinary day. No eclipse that day, just the round image of the sun. However, during an eclipse, the sun's image is no longer round because the sun is partially blocked by the moon. And so the images created by light filtering through tree leaves don't look round anymore, but look like this. Because the sun at a certain point during the eclipse might look like this. That's the image of the sun, sort of crescent in appearance. So it creates crescent images of the sun on the ground. Now, this picture, of course, was taken in a different place for a different eclipse. And also, I'm not sure how many leaves will be on trees on April 8th. So this effect might not be something so easy to see at this particular time of the year. But if you're going to be in Lexington, and I do recommend you attempt to make it into the path of totality if that's feasible for you. But if you're going to be in Lexington, then the Department of Physics and Astronomy is offering a eclipse viewing opportunity at what's called Alumni Commons. It's the new pedestrian walkway at the corner of Rose and Columbia on campus. Here you see a map of the path of totality with the shadow of the moon at different times along that path of totality. You can see in this map, for example, that the path of totality just barely covers the westernmost part of Kentucky. In any case, on the day of the eclipse, Monday, April 8th, between 2 and 4:15, the Department of Physics and Astronomy will be set up with a few small solar telescopes and a supply of eclipse glasses, which will be given away, until supplies are exhausted, so that you can safely observe the eclipse. Now, you can observe the eclipse in your backyard if the weather's good. You don't necessarily have to come to campus, but it might be fun to come to campus, hang out, get your free eclipse glasses, and gaze safely at the eclipse. We'll talk about eclipse safety coming up in just a moment, because that's very important. So let's do that right now. How can you protect your eyes? And the answer is you always should use eclipse glasses to view the sun directly. Now, people sometimes ask, is it more dangerous to look at the sun during the time of an eclipse than it is on an ordinary sunny day? And the answer is no. Anytime, if you look up at the sun on a clear sunny day, and you look at the sun and then look at it again and look at it again and again, you'll damage your eyes. So the sun is no more dangerous during an eclipse than it is during an ordinary sunny day. But the thing about a solar eclipse is that there is, on that day of an eclipse, a reason to keep looking at the sun. And if you keep looking at the sun without proper eye protection, you will damage your eyes. Ordinary sunglasses are not nearly dark enough. But eclipse glasses, and you see one here on an old man, eclipse glasses are so dark that the only thing you can see through them is the sun. They are much, much, much darker, much, much, much darker than even the darkest sunglasses. There is an exception to this rule about always using eclipse glasses to view the sun directly. And that exception, which I'll mention again in just a moment, is during the total phase, a few minutes of totality, as we call it, the total phase of the solar eclipse, which only will be the case for people in the path of totality, will never be the case, at least for this eclipse here in Lexington. A few tips about eclipse glasses. They're not expensive. They're just made out of thin cardboard and a special type of plastic that absorbs almost all of the light of the sun. They can be purchased locally, perhaps a few dollars a piece. Local outlets, I understand, have them for sale. But we, as I say, during the eclipse viewing event on campus at the Alumni Commons that I just mentioned, during that eclipse viewing session, we will have a supply of eclipse glasses to give away while supplies last. Folks are welcome to take them. You do want to make sure that there are no scratches or pinholes in your eclipse glasses filters. You might want to just look at them briefly before you put them on to look at the sun. Don't use eclipse glasses with binoculars or a telescope. Somehow, if things don't work out right, your eyes could be damaged. Also, as you see here on this slide, verify that eclipse glasses meet what's called the ISO standard. That should be stamped somewhere on the eclipse glasses, as you see in the lower left of this diagram. So it's very important. It's very important, as I say, during a total solar eclipse, during most of a total solar eclipse is very important. When even a small fraction of the sun's disk remains uncovered by the moon, very important not to look at the sun unless you have eclipse glasses to protect your eyes. Now, there is one exception. If you are in the path of totality, if you've planned ahead, or just decided to try to get there on the day of the eclipse in the path of totality, let's say you decide to drive to Cincinnati and head towards Indianapolis, or else drive to Louisville and head towards Indianapolis to get into the path of totality for this eclipse during the few minutes of total eclipse. By few minutes, I mean 3 to 4 minutes. During the few minutes of the total eclipse, if you're in the path of totality, which of course you have to be to see the total eclipse, the eclipse glasses are not needed during that brief few moments when the entire disk of the sun is covered by the moon. During that time, take off your eclipse glasses. The outer atmosphere of the sun, the corona, which will now be visible, will be about as bright as the full moon and therefore perfectly safe to observe. And so during that brief time, look up with your naked eye, if you're in the path of totality for those few minutes, and gaze at this unbelievably spectacular phenomenon of nature, which is exquisitely predictable. We can predict, astronomers can predict eclipses centuries, even millennia into the future, and they can determine when eclipses occurred centuries into the past and even millennia in the past. We'll see one interesting aspect of that coming up in just a moment. So don't do this. This was the eclipse of August 21st, 2017. Apparently, a certain politician did not initially get the memo regarding eye protection, but then eventually did. And so all is well as far as I know in that respect. So you might ask, well, what if I missed this eclipse coming up on April 8th of this year? What are my options in the future? As I said, eclipses can be predicted well into the future, and for that matter, back into the past. So here now are the paths of totality of various eclipses for the first half of the 21st century. Most of these eclipses have taken place. The one on April 8, 2024 is shown. If you miss that one, the next eclipse that will be visible across most of the continental United States will be on August 12th of 2045. Now, I'm hoping to last long enough to see that, but I'm not so sure. I'll be 97 years old during that eclipse, so I have a feeling I might miss it. I am going to be pretty old if I'm still alive at that time. But many of the people hearing my voice now, people much younger than I am, will surely be alive in 2045 and will have another opportunity to see a total eclipse of the sun. That eclipse of 2045 is the next eclipse of the sun for which the path of totality passes across the continental United States. Of course, if you have a very rich travel budget and you can travel anywhere in the world to see a total solar eclipse, then you would be able to see a total solar eclipse about every year to a year and a half. But if you plan to stay in the continental United States, your next total solar eclipse opportunity, August 12th, 2045. Now, here is looking even further into the future. The second half of the 21st century, here are various eclipses. I don't think I'm going to make any of these, but there might be some within the sound of my voice who will see some. Again, the purple strips that you see represent the paths of totality for various eclipses, and the dates are given there, as you can see. Now, you might ask, well, when was the last total eclipse visible in Lexington? When was the last total solar eclipse visible in Lexington? As I pointed out, this eclipse coming up in April is not a total eclipse in Lexington, although it is about a 95, 96, 97% total eclipse. Having said that, let me point out that the difference between a 95, 96, or 97% total eclipse and 100% total eclipse is almost like the difference between day and night. You know, if I said I was going to give you $100, but then I later said I can only give you $98, I can't give you $100, you'd probably figure, well, what's the big deal? A couple of bucks, pretty much the same as $100. $97, $98. But with eclipses, it's completely different. The difference, as I say, between a total eclipse seen only in the path of totality and even a 95 or 96 or 97 or 98% eclipse, the difference is huge because the sun's disk is so incredibly bright compared to the corona of the sun that's only seen during a total eclipse. So the beauty and the drama of a total solar eclipse is something that vastly exceeds what can be seen during any partial eclipse, even a partial eclipse that's in the high 90% total, but not 100%. Of course, if you can't make it to the path of totality, many people have work commitments, school commitments, all kinds of commitments, daycare, childcare, whatever, work. If you can't make it to the path of totality, but here in Lexington, it will still be an interesting thing to observe. Now, here is the last total solar eclipse seen in Lexington, August 7th, 1869. So that would have been during the presidency of Ulysses S. Grant. You can see the path of totality there in Lexington shown within the path of totality. When will the next one be? When will the next path of totality be? Well, it turns out it really doesn't matter because we'll all be dead at that time. The next total solar eclipse for which the path of totality includes Lexington will be, as you see, on October 17th, 2153. I think I'll probably miss that one. Not sure. Yeah, I am sure. No way. You see, because the path of totality of a given solar eclipse is so narrow, it only covers a very small fraction of the surface of the Earth. Each total solar eclipse has a different path of totality. They all sweep from west to east, but in different directions and across different parts of the Earth. So on the average, a given location, like say Lexington, will be exposed to a total solar eclipse, will be within the path of totality maybe once every 2 or 3 centuries. In this case, we have to wait another 129 years for an eclipse that is total, as seen in Lexington. Now, as I mentioned, not only can astronomers predict eclipses into the future, centuries and even millennia into the future, but they also can calculate when eclipses occurred in the past. And that brings up an interesting item regarding the Christian Bible. In the Christian Bible, at least in one version, it is written, "It was now about noon, and darkness came over the whole land until 3 in the afternoon because of an eclipse of the sun." This was during the crucifixion of Christ. And you see this shown in this painting by Rubens. Going back many centuries, the yellow arrow points to what is obviously a representation of a total eclipse of the sun. Now we can ask, was in fact there an eclipse of the sun that would have been visible in the Middle East during any period of time that might be reasonable for the life of Christ? And the answer turns out to be yes. Here it is. On November 24th, 1829, a date that is certainly within the lifespan, as we understand it, of Christ, there was an eclipse that was visible in the Middle East. And you see the path of totality from upper left to lower right, passing through, for example, Syria. And you see Jerusalem pointed out there by the arrow at the bottom. Christ was crucified in Jerusalem, but Jerusalem was not in the path of totality, but still it wasn't that far away. So as seen in Jerusalem on November 24th, 1829, as seen in Jerusalem, the eclipse of the sun would have been 90% total and certainly would have been noticeable, although nothing like a spectacular total eclipse of the sun. So who knows? Who knows? If that passage from the Bible is literally correct, then we could be certain that the crucifixion occurred on November 24th, 1829, because that's the only time that there was an eclipse of the sun that would have been even slightly visible in the Middle East during the period of time that Christ lived. Interesting to think about. We don't really know, but nonetheless, it's an interesting thought, and also an example of the ability of astronomers to calculate eclipses past and present with great precision. Now, I'd like to end with this reading here. It is a description of a total solar eclipse of August 11th, 1999, which was visible in Europe and Asia, and which I witnessed in France, a very memorable day in my life. And this author wrote as follows: as the moon obscured more and more of the sun, and the sky darkened to a shimmering violet, cicadas, confused by the noontime dusk, began calling out their evening song. The temperature dropped. A breeze kicked up. When the eclipse was total, I removed my special eclipse glasses, essential for viewing the eclipse phases safely, and I casually looked up at the sun and staggered back a little, my brain reeling. The transformation of reality in a total solar eclipse is indescribable. It sure is. I was mesmerized, disoriented, shocked, as if I had slipped through a wormhole to an alternate universe. I was the unwitting star of a Twilight Zone episode. Mere minutes later, the sun peeked back out from behind the moon, and all was familiar again. As suddenly as it had begun, my first total solar eclipse was over. But, like thousands of others around the world, I was hooked. And I will end by pointing out that if you have the extraordinary good luck of positioning yourself within the path of totality of this eclipse coming up on April 8th of this year, and if the weather is clear and you see that eclipse, you too will be hooked, as I was many years ago. Thank you very much, and good luck to you in observing the eclipse if that's what you wish to do. So long.